Hello everyone, welcome to this presentation of AppArmor and HTTP. My name is Patrick DeBerry and we will be talking about what both these security features are, how they work, and how to harden them to make for even better security. So first off, we have AppArmor. AppArmor is a security module built in the Linux kernel itself. It comes automatically enabled with all Linux distributions. It assigns mandatory access controls to applications and processes via profiles. And profiles are text files that define the confinement rules for each process and application. They're located in the AppArmor directory in etc/AppArmor.d. And more profiles can be downloaded from this command right here, the sudo apt install AppArmor-profiles. This AppArmor-profiles, this is what is called the profile package for AppArmor. Not all profiles will be enabled after the install though. Some of them you will actually have to manually go in and enable them. For example, Firefox. It has a profile that can be downloaded, but you yourself have to actually go in and enable it. So for every application or process that you have on your Linux server, there is a profile for it. If, however, there is not a profile for an application that you may have recently downloaded, you can create one. However, it is important to know that it's only recommended to create profiles on an absolutely necessary basis. And that's because a misconfiguration can lead the process or application you have a profile for to having too much privileges or too much access, which can lead to a vulnerability, or it can not have enough and they lose functionality or maybe not even work entirely. So that is important to know going forward. And profiles are named after the full executive path. So that includes the directory as well as the full path. And then after the directory, slashes are replaced with periods. So for example here I have, if you have something like /user/bin/Firefox, it turns into user.bin.Firefox, and the full name would be /etc/AppArmor.d/user.bin.Firefox. And you probably will want to edit a profile at some point using AppArmor, and to do so, well, after you do so, you will have to reload that profile before it will be enabled and working. Profiles can be run in one of two ways, either complain mode or enforce mode. Complain mode is more used for testing purposes. You can allow it to violate their app's permissions and then log it, so you can kind of analyze it, make adjustments, see how the profile works, what needs to be improved, etc. Once you're actually comfortable with your configuration and how it works, then you can place it into enforce mode. And in enforce mode, it will actually enforce those permissions that you gave in the profile and log any violations. Complain is like practice mode, enforce is like real deal. And then for the profiles themselves, they have two main rules, either path entries and then capability entries. So capability entries, they state the capabilities that each program has according to the POSIX draft capabilities. And then the path entries specify what areas of the file system, like what files they can have access to and what they can't. Here we have some of the AppArmor permissions. As you can see, these permissions can get pretty complicated and complex pretty quickly, so it is best to be used with caution. For most purposes, administrators will probably need only concern themselves with the most common ones like read, write, append, maybe link and lock. They're probably most of the time not going to be using any of the UX, PX, CX, things like that. But they are there if you do need them. And then letters can also be combined to perform multiple permissions. For example, if you want read and write permissions, it would just be RW. So here we have some of the more common commands used in AppArmor. AppArmor is a command line only program, so there's no GUI for it, so it would be in your best interest to get familiar with some of these if you're going to use AppArmor, because you'll probably use these commands quite a bit. First thing we have is something that's commonly used as the first command, and that's checking AppArmor status. AppArmor does come enabled by default, but maybe someone disabled it either on purpose or accidentally at some point. It's just always a good idea to check that it's up and running, make sure. And that is represented by this command, sudo AppArmor_status. Nothing too complicated there. Next we have complain/enforce mode, and that's represented by AA-complain or enforce, whichever one you're trying to do. Next is to create a profile is AA-genprof, which stands for generate profile. And finally, load/reload, which you will have to do when editing a profile. Again, if you edit an existing profile, you will have to reload it before it will be enabled. And that is AppArmor_parser. That will allow you to load it into the kernel. I didn't include it, but these last three will also need to be run with administrative privileges, so you will need to include this sudo before these commands as well. Alright, now we're going to move into HTTP. What is HTTP? Well, it stands for Hypertext Transfer Protocol. It is an application layer protocol, so if you're familiar with the OSI model, that is the 7th most layer. And it is the protocol used when surfing the web, which all of us just about do every day. And it is part of the greater TCP/IP family. So if you want to enable HTTP from your server, you will have to enable port 80 for TCP. Web browsers act as HTTP clients on behalf of users. So every time you open up Chrome or Firefox or Internet Explorer, whichever you use, they're actually building HTTP packets to send for you. So how does it work? Say someone wants to buy shoes from Amazon. So they pull up their web browser, perhaps they use Google Chrome, and they pull Google Chrome up on their laptop. They type in the URL amazon.com. And what they're actually doing when they do that is they're pulling up an HTTP client, Google Chrome, and by typing the URL, they're asking, hey Chrome, can you build an HTTP packet for me and send it to Amazon and ask for the binary code that makes up the HTML language so that I can access and view their web page? And Chrome says, yeah, I can do that for you. So it sends the packet to an Amazon web server that is equipped with a daemon, and the daemon's job is to listen to these requests and respond to them all day. So the server sends back a response to Chrome that contain the files of the web page. These files hold the content of the web page itself, like text, pictures, videos. All these are included in files. Now that we have an idea of how HTTP works, let's move on to the different types of HTTP. First up, we have HTTP/.9. This was the most simple, basic, the first version that came out, and it was one request per connection. So every time you connected to a web server, you were only allowed to send one request. This became a problem because nowadays web pages have so much audio, video, pictures, text, you name it. There's so much of it that require them to be held in so many files, and that obviously takes more than one request to receive. So enter HTTP/1.1. This kind of solved that problem by having default persistent connections. And what this was enabling them to do is send multiple requests at the same time, and this is called HTTP pipelining. So they didn't have to connect to the web server every time. They could just send multiple requests and get multiple responses back with just one connection, and this allowed for faster loading times and quick searching, and life is good. Finally, we have HTTPS. This is considered the most safest type of HTTP because it encrypts connections with either TLS or SSL, mainly today using SSL, which uses asymmetric encryption, and that means it has private and public keys, which protect things against things like the man-in-the-middle attack, in which a hacker intercepts a message that you sent out between the client and the server. If he gets that and you're using HTTP, he will be able to read everything in that message, including any sensitive information about either one of the machines in communication with each other. If you're using HTTPS, however, it will be encrypted and he won't be able to read it. The only way he will be able to read it is if he has access to your private key in order to decrypt it, which, I mean, you're not going to give him your private key, at least not willingly. So that's why that one is considered more secure. Alright, so now we get to move on into the fun stuff, which is the second part of this presentation, hardening tips. So the first tip I have for you for AppArmor is get desktop notifications on denied actions. I say this because apps have vulnerabilities. Programmers aren't perfect. So if one day it ever is compromised, then AppArmor will automatically mitigate the damage from the permissions and restrictions you put on it from the profile. So that will already be done automatically, but with notifications, you will be able to know immediately when someone is in your system, maybe trying to escalate privileges or gain access to files that they're not supposed to, and that may have sensitive information on them. And then you can try to put a stop to it right then and there. And below, we have the steps to enable that according to wiki.arxlinux.org. The second tip I have for AppArmor is to enable Firefox. Firefox is a web browser commonly used in Linux environments, so that's probably the web browser that you're going to be protecting when you're using AppArmor. And this is important because web browsers have a lot of access to things on your machine, including any passwords that you've saved, any files you've given it access to. It sends and receives HTTP packets that contain sensitive information about your system. So it's important to protect these applications. And the good news is that Firefox already has a profile created that you just need to install, and you can install it from the profile package using this command, the sudo apt install AppArmor-profiles. This is the profiles package, and then you can enable it by the command sudo aa-enforce / the executive path that Firefox is in. Or you can choose to run it in complain mode first and see how you like it. And if you want to make changes to it, you can. That would be a good method as well. All right, now we're going to look at some hardening tips for HTTP. So I didn't mention this earlier, but there's a lot of methods that HTTP can use to go about its business. In the previous example with the shoes and Amazon, that would be an example of probably a GET request method in which the Chrome would send a GET request to the web server, and then the web server would then send a response. That's a commonly viewed safe method. There's some other similar methods that are also considered pretty safe, but there's also these other methods like the trace method. The trace method is infamous for being an exploit in the cross-site scripting attack. And how the trace method works is when you send a request to a web server, that web server will echo your message back. And in doing so, it can disclose some sensitive information in the packet headers, like IP addresses for either the server or your machine, which can be advantageous to hackers. So it is best to disable it. The track method, that came from Microsoft. It kind of works the same way as the trace method and can be used in the same way as an exploit. So best to disable that one as well. Both are kind of rarely used. Definitely not as much as the others, more common, safer methods. So if it's not going to be used, just disable it. So we've kind of already touched on this a little bit. HTTPS is safer than HTTP. It can prevent damage from man-in-the-middle attacks, protect your data while in transmission, which is always a good thing. You know, don't be a victim, protect your data. Here's my references page. Has a lot more information about what we've already talked about, and some help guides about troubleshooting if you have any problems, and just packed full of good information. So I recommend you check it out if you can. Congratulations, you made it to the end. The torture is over. That's all I have for you today on AppArmor and HTTP. As always, leave some comments. I look forward to reading them. And until next time.